Stingray's secret, how they hunt in murky seas. For many of us, sunlight is a constant companion, illuminating our path and shaping our world. But imagine a life lived almost entirely in darkness. That's precisely the reality for numerous stingray species inhabiting the depths of the Black Sea and Mediterranean Sea. These aren't shallow coastal waters. We're talking about environments where sunlight barely penetrates. The water column here can be incredibly deep, exceeding 3,000 meters in some areas of the Black Sea, effectively creating a world devoid of light for these amazing creatures. They've adapted remarkably to this challenging existence, relying heavily on sensory systems other than sight-sensing vibrations and electrical fields in the water to locate prey and navigate their surroundings. It's a testament to nature's ingenuity that life can thrive even under such extreme conditions. Most fish rely on sight to locate their next meal, but stingrays have a truly remarkable adaptation. They depend heavily on something called electroreception. Essentially, they feel the electrical fields generated by other living creatures. Every animal produces tiny electrical signals from muscle contractions to nerve impulses. Stingrays possess specialized sensory organs called ampullae of Lorenzini, clustered around their head and snout. These act like incredibly sensitive detectors, allowing them to pinpoint buried shellfish, crustaceans, or even fish hiding in the sand. It's a fascinating way to navigate and hunt in murky waters where visibility is limited. Stingrays possess an incredible sensory adaptation. Their skin is dotted with thousands of tiny pores called ampullae of Lorenzini. These aren't just simple holes, they're complex structures filled with a jelly-like substance that conducts electricity. Think of them as biological antennas, allowing the stingray to perceive the faint electrical fields generated by other living creatures hidden in the sand or murky water. This ability is particularly useful for hunting prey like shellfish and crustaceans, which often burrow beneath the seabed where visibility is limited. It's an amazing example of how evolution has equipped these animals with a unique way to navigate and find food in their environment. Stingrays possess an incredible sensory ability. They can detect electrical fields. Imagine trying to hunt in complete darkness without sight or smell. That's essentially what a stingray faces when searching for food buried beneath the seabed. These specialized organs, called ampullae of Lorenzini, are incredibly sensitive and pick up on tiny electrical signals. Every muscle contraction by a potential meal, whether it's a crab, clam, or even a small fish, generates an electric field. The stingray's ampulla can detect these faint signals, allowing them to pinpoint prey hidden deep within sand or mud, often completely unseen and undetectable by other means. It's like having a sixth sense for electrical activity. It's truly remarkable how stingrays navigate their world. They don't rely on sight as much as you might think. Instead, they possess an incredibly sensitive electroreception system. This allows them to detect the tiny electrical fields generated by other living organisms, even when those organisms are hidden from view. Imagine trying to find dinner buried beneath a layer of sand and mud. A stingray can pinpoint a clam or another small prey item buried as deep as 10 centimeters or about 4 inches below the surface. It's like having an underwater radar that detects life itself, a vital adaptation for survival in murky waters. Stingrays are masters of their underwater environment, and one remarkable technique they employ is what scientists call bottom scanning. It's a truly fascinating way for them to locate prey hidden beneath the seafloor. They glide incredibly slowly along the ocean floor, using their large pectoral fins, those wing-like structures you see almost like paddles, gently pushing themselves forward. As they do this, they're not just drifting, they are constantly analyzing electrical signals emanating from buried shellfish and crustaceans. These tiny creatures generate faint electrical fields as part of their natural biological processes, and the stingray's highly sensitive electroreceptors pick up on these subtle clues. Stingrays are masters of adaptation, and their hunting strategies exemplify this perfectly. Imagine trying to find food when all you can see is a murky cloud of sediment. That's the reality for many stingrays living on the ocean floor, where sunlight barely penetrates. Their electroreception, those incredible sensory pores covering their bodies, allows them to essentially see with electricity, detecting the minute electrical fields generated by even buried prey. This method allows them to hunt effectively in environments where visibility is extremely limited, giving them a distinct advantage. They can pinpoint hidden crabs, clams, and worms that would be completely invisible to creatures relying solely on sight. It's like having an internal sonar system, providing an unparalleled edge in low-visibility habitats. It's truly remarkable how these creatures navigate their underwater world. Stingrays don't just blindly search for food, they possess an incredible sensory ability that allows them to pinpoint exactly what's beneath the seafloor. Each living thing, a snail, a squid, or even a clam, generates a subtle electrical field. These fields are unique fingerprints, and the stingray's electroreceptors act like incredibly sensitive detectors, allowing it to differentiate between these signals. Imagine being able to tell the difference between a snail and a squid just by sensing their tiny electrical hum. This specialized sense gives them a significant advantage in murky waters where vision is limited. It's easy to think of electroreception as just a tool for hunting, but it's so much more than that. These amazing sensory organs are like an early warning system for stingrays. They can detect the faint electrical fields generated by the muscle contractions of other animals, and those aren't limited to potential meals. Larger predators, like sharks and seals, also create these detectable signals as they move through the water. A stingray can sense their approach long before it's visible, allowing them to quickly bury themselves in the sand or swim away to safety. It's a vital defense mechanism that significantly increases their chances of survival. The stingray's electroreception is truly astonishing. Imagine being able to sense the faintest electrical fields generated by hidden creatures buried in the sand. These animals possess thousands of tiny pores called ampullae of Lorenzini scattered across their snouts. They function like incredibly sensitive detectors, picking up the minute electrical signals produced by a flounder hiding beneath the seabed, or even the muscle contractions of a crab scuttling along the ocean floor. This ability isn't just about finding food, it allows them to navigate murky waters and detect predators lurking nearby. giving them a significant advantage in their environment. It's a testament to evolution at its finest, allowing these graceful creatures to thrive where vision alone simply wouldn't suffice.